So I will present some projects we have with our French and European partners that has been presented. What are the collaborative projects? I guess most of you know, but it's a way for us, for Aldebaran, to collaborate with academic institutions, researchers, and also other industrial partners to test new technologies, to test new scientific developments, and to try to integrate new features for a product. And of course, this is research, but this research is dedicated to go into our future products and to test future applications, and mainly the application in personal assistance. Because what we have in mind for at Aldebaran is that robots are dedicated to assistance to people, to help people, to make the life easier. And so most of our application, the application we target in the collaborative project are for personal assistance in medical, health, care, or any other kind of assistance. On which technology we want to work with these partners? On mechatronics and on software. Mechanical design, we want to have a always better robots, mechanical, electronical, low-level software, but we want to work on new actuators, new sensors, to have the robots always cheaper and more reliable. And we are really sure that there is something that should change in the way we design mechanics of our robots. And of course, a lot of software. Most of the development I will present tonight are about software, how to improve the walking, the grasping, the way the robot navigates. Because if you don't have that, you can't realize applications. And all this stuff, all these features are really necessary. So we are looking for French, national, and European project in every kind of framework you can find, FP7, FEDER, and so on. So we used to have up to 12 collaborative projects together. So it was quite difficult sometimes to be very efficient of each of them. So today we are focusing on less projects, and we have very big projects. And here you have the matrix. In each project, we are dealing with some technologies. In black, here are the projects where we are leaders. So we build the project, and we looked for partners to develop the technological bricks we were looking for, or we have our own development on it. And in the white project are the project where we have been invited to bring the robot to help our partner to integrate the development on the robot. And we bring new development by ourselves, and we try to evaluate, as I said, the technology of our partners. So as you can see on ROMEO is a big project that we started in 2009 and that ended in 2012. And we are starting a new ROMEO project, a ROMEO 2 project that just started maybe last month, and for 4 years. And because we designed this project, we can work on all the projects on the technology we're interested in. So now I will give you some example of what we're doing, and I've tried to gather some projects because of course we don't change all the subject of the project when we work on different projects. So on these projects, GRASPI and ROMEO. GRASPI is an ECORD project, so it's a small European project, and we work with the FKI on this subject. It's about grasping, how to grasp object with now. And for GRASPI, we develop a stereo head. And with a stereo head, we put the two cameras in the eyes of now, and then we can have a 3D measurement of the position of the object. And DFKI, our German partner, I don't know if we have the sound working, but so the FKI developed we developed the hardware of the stereo vision head, and they developed the software, stereo software. And here you can see how now is very surprised to see this cup. But after, he can follow when he detected it, and you know, he has a whole body motion to fit its position according to the object to grasp. As you know, the workspace of the arm of Nao is very small, and the stereo vision field of view is very small as well. So there is only a small overlap between the workspace of the hand and the field of view of stereo vision. So that's why if the object is not exactly in the good position, it's difficult for Nao to grasp it. But here, you could do it, and then
give it to me.
Thank you. This is for you.
And here we have a small feature where the robot detects that someone wants to take the object, and the robot.
Ça a été pas mal là, celle-là.
You can hear the voice of Alex Mazel with the star of the developer at Aldebaran. Most of the demo that you will see here are prepared by Alex. And in this one, for the robot project, here is Alex.
A spoon.
Spoon. I'll bring you that.
Here, the robot will bring an object, but in the previous example, the man gives the object. So it's easy for the man to adapt the position of the object to grasping. Here, the tool is somewhere, and then the robot has to grasp it. Here we don't have the stereo vision head, so we help the robot with the QR code that you can see here. So the QR code will help the robot to detect where are the objects and which are the objects. There is a different QR code for
I saw it.
Which can detect the QR code at a certain distance and then walk to it.
I'm well oriented.
And as you probably know, the odometry of Nao is not so good, so you cannot walk straight forward without having a visual landmark. So you target the data of the QR code and then can walk towards the object. And when it's close enough,
fan approach.
he has to go to fine approach and then adapt the good position of its body to have so sometimes he has to walk because the distance is too big, and then with a roll body motion he can adapt precisely its position for the grasping. And as you can see as well, we have put some color bulbs on the spoon, so it makes the grasping easy. But for a robot as simple as Nao, we can consider that
it's
possible to help him
It's for me.
to detect the object.
Okay, I'm coming.
And of course, the more powerful your software will be, the less landmark we have to put on the object. Of course, at the end, we would like to get
Thank you.
Don't forget to give them back.
And the green or red mark on the object. So in RoboHo, it's a European project, huge European project, where the object is to make the robot able to learn how to cook, for instance, a pancake. So the robot will look on internet. You ask a pancake to Nao. He says, I can't do pancake. So he will go to internet, look for recipe of pancakes, read the recipe, complete, because when you read the recipe there is a lot of information missing, because when you are human you can, when there is a recipe you can infer the missing words, but for a robot when you say you have to move the flour, that they don't say that you need a spoon for that. So the robot has to infer that he need a spoon. So this is kind of development these people are doing, and then the robot will try to do the same gesture that the human does when he, for instance, cooks pancakes. So in this project, we are supposed to provide a ROMEO and to work on the object recognition. That's why this demo was a first step for us. And then the navigation. The navigation is very useful. We asked the question: how do you know where is the person and how you can go to the person? So for the navigation from a place to another, it's very complex, and for now is almost even more complex because it doesn't have very good view, doesn't have laser, doesn't have a good way to localize itself. So here we have put a laser on the head of Nao, and we have first interactive exploration of the room.
Où suis-je?
C'est l'entrée.
Ok, alors un dedans, ici, ça sera l'entrée.
Okay, this development is at the end for Romeo, so the Romeo will walk faster and the upper flat can be bigger. But for now, because we have a limited time, we have make a small flat, and I have speed up the picture. So, and so on.
Quelle est cette pièce?
C'est le couloir.
Okay, last room.
C'est la chambre des enfants.
Ok, alors un dedans, ici, ça sera la chambre des enfants.
Voilà, je crois qu'on a compris l'idée. Hein.
So it goes in all the rooms, and then the robot has a map. This map is not so very nice, but it's enough for now to know where it is and where it has to go. And then he said, "What do you want me to go?"
Va dans la chambre des enfants.
And the robot doesn't move.
S'il te plaît.
And when it's walking, Alex can ask, "Where are you?"
Où es-tu là-haut?
Je suis dans le couloir.
So here, for instance, if Alex is in that situation, he can call and say, "I'm in the children's room, come to me." And now say, "Okay, I come," and we will explain, "Okay, I'm now in the corridor." And
Ok, très bien.
so to make this first demonstration of navigation, we have equipped now with this laser, and now we are working on a classical standard now without the laser, but we equip the environment with this QR code that you've seen. So we put a lot of QR code in the environment, and then the robot is able to learn the environment based on these QR codes. Here is I will probably skip this one. It's about the object recognition. Oh, it's very fast, but it's once again it's how the robot can recognize objects without QR code or any artificial landmarks or marks put on in. Here, the robot has learned the box of these medicines, and it is able to recognize them.
Une boîte de physiologica, lavage oculaire ou des fosses nasales des nourrissons, enfants et
And he
adultes.
explains what are these medicine for. And he'll ask,
De quoi as-tu besoin?
"What do you need?"
Pulmicor.
So Alex asks Plumicor because he had a bad breath.
Pulmicor.
Pulmicor. Ok, je vais chercher le pulmicor.
So once again, we have this walk towards a visual target. And when the robot is close enough,
Et Roméo, toi qui as des grosses paluches, viens m'aider à
so you can
attraper
hear,
cette
but he
grosse
say,
boîte
"Romeo,
de
come,"
pulmicor.
because you have big hands, so you can grasp this object, and I can.
J'arrive.
So once again, this demonstration will be reused with a Romeo. My last demo was about taking care of people in that situation, but you saw it just before. So this JULIETTE project is a European project, FEDER, and the application is how the robot can understand the gesture and the activity of a person. So just the robot is just looking what you're doing, and if you ask robot come to me, only with his vision he can detect the meaning of the gesture you're doing, and also the activity. If you're cooking, if you're putting your keys somewhere. So this recognition of activity is and gesture is developed by Telecom Sud Paris. And what we want to do is to integrate a lot of software, visual processing, into a dedicated processor, an ASIC that is developed by a French company called BVS, Brain Vision System, and they want to put just behind the sensor a lot of pre-processing in order to have for the main CPU, the atom that you know that is quite weak, not weak but not strong enough to make all the computation we want to do, if we can have a lot of pre-processing done in dedicated components, everything will be easier. So that's what we are developing within this project. So there is a short video, but you've seen it in the previous presentation. The only difference we have, the robot is able to detect, because this project is about vision, the robot is able to detect a fallen down person only by looking at the color of his clothes. So you know, it learns the color of the clothes, and when he sees these colors lying down on the ground, he understands that there is something special, and then the robot comes close, asks, is everything fine, and then if it's not, someone can take the control of the robot. I will finish with some news of ROMEO, because a lot of people are waiting for ROMEO, and we are. But we're working hard on ROMEO. At the end of last year, at the end of the first ROMEO project, we had this prototype realized with motion of the legs, of the arms, of the head. So we had this first prototype, and we are not very happy with that. So we wanted to make a lot of improvements, and we had orders. 4 labs in France and in Europe asked us to have ROMEO, and it was difficult for us to only duplicate this first prototype that was just a prototype, and we had to improve it before delivery. That's why it's so long, that's why we are late. But I really think that it's worth it, because we don't want to deliver an object that will fail. It's not good for us, it's not good for the work of our partners. So we prefer being late and pay what we have to pay than deliver something that we are not proud of. So for instance, we changed the joint of the hippo. I don't know if a lot of people are interested by mechanics stuff here. Are you? Yes? So we changed this classical and bulky actuator with gears and a vertical motor by a very nice and smart jack that we can put. This is the pelvis. I don't know if you see. This is this part, and this actuation is for this motion of the leg, what we call the yaw of the hip. So we've changed that. We changed the head as well. In the head there is plenty of device in it. 3 atom CPUs, a cooler, the fan, the hub, 2 mobile aids that can move, and 2 fixed eyes in the forehead, the loudspeakers, 4 microphones in the standard version, but we'll have a version with 16 microphones. The LED, same kind of LEDs that you have on the hat, on the now, and the tactile sensor on the scale. In the first prototype that I presented, everything was assembled in the 2 shells. So it was very difficult to assemble everything in the shells and then to close the shells. So what we've done, we add this internal yellow structure that you can see, and we plug everything on it. And then the shells are only for aesthetic reasons, to hide what is inside. And for instance, if you want to change the look of the robot according to the application you want to do, it's much easier. So we'll have a better wiring, so easier assembly, and a much better reliability for the head. And I'll finish with the major change we made between the first prototype and the new one. It's about the mechanical, the torso. The torso is this part of the robot where we plug the arms, the head, and the vertebral column. Originally, we have this huge, massive piece of plastic that you can see on your left, in which we plug everything. So it was bulky, it was difficult to put all the stuff inside, and it was difficult to assemble, because for instance for the neck we have to put everything from below. So if we want to change the neck, you have to disassemble everything. So we changed for this very light structure and bio-inspired structure that you can see here, made of titanium, and in which everything is much easier to plug into. It will be easier, stronger, and it's also prepared for what we call compliance. It means a possibility for the structure to change its shape when you push on it, and that for a way for us to have a robot smoother and less fragile and less dangerous. And then you can plug everything on this new torso. And with this new torso, we have some more freedom to change the design of the external shells. So here are the design that we have tested. So as you can see, it will be even more beautiful than before. And with the classical buttons that you can find on your robots. Yes, for now you don't have the emergency stop. For a big robot like ROMEO is, we need it. So we'll have it. We can have it after a long wire to make it simpler. Everything to reload the batteries as well. So we have these 3 or 4 possibilities, and we have selected this one that is designed with the CAD software yet. So here we are, and I really hope that for the next day you will see the ROMEO, and I hope much before. Thank you very much. If you have questions, we have some time for it.